In this module, we will cover the proxy pattern, also known as the surrogate pattern. It's intended to provide a surrogate or placeholder for another object to control access to it. I'm Kevin and I'll guide you through this module. We'll start by describing the pattern using a real-life example. As an example, we will use a remote API call for starters. After that, we will map that to a structural example. Then we will look into variations of the proxy pattern, because there are a few. We'll also choose an example to implement in a demo. We'll continue with learning about use cases for this pattern and pattern consequences. And we'll end the module by looking into related patterns. Let's dive in. The proxy pattern is a structural pattern from the well-known Gang of Four design patterns. Its intent is to provide a surrogate or placeholder for another object to control access to it. That's important to know, because this means that the reason for this pattern, the problem it solves, is one of access control. If you need to control access to another object, for security reasons, performance reasons, or other reasons, then the proxy pattern is a good one to look into. The archetypical example of a proxy, which some of you have undoubtedly encountered, is accessing a remote API from an application. Those of you who remember the Add Service Reference option in Visual Studio will know about this. The idea here is that your application, let's say it's an MVC app, uses a proxy to interact with the actual remote API. That proxy can be completely written from scratch. But as mentioned, there's something like the Add Service Reference dialog, which would generate a proxy for you. So the proxy is responsible for controlling the actual access to the actual remote API. It can contain code that deals with the underlying protocol, for example, the actual HTTP client calls. It can also contain code that ensures that the most performant, reliable way to access that remote API is used, and so on. In principle, these proxies have the same interface as the object they're controlling access to. So for the client, it feels transparent. The client shouldn't care whether it's directly interacting with a remote API or it's going via the proxy. But truth be told, sometimes you see code generators generating what they call proxies that don't adhere to this principle, which makes them more of a combination between a facade or adapter and a proxy maybe, but that's another discussion. Anyway, the question remains, why would we want to do that? Why not directly call the API with an HTTP client instance? You can see an example of that on screen. Well, imagine that you need to execute something right before or after calling the API with HTTP client, which isn't uncommon. When you have a proxy in between, the proxy can take on that responsibility. That means that you don't have to change the client class anymore. Note that a proxy does not change the interface. If that is a requirement, you might want to consider the adapter pattern. Let's have a look at the proxy pattern structure. The first player in the proxy pattern is called the subject. This is what defines the common interface between two other classes, the real subject and the proxy. It's the contract both of these adhere to. Map this to our remote API call example and you could see this as a service contract, say with one operation on it, request. The subject can be written as an abstract class, but it can also be implemented as an interface. Real subject implements this interface. This would be the remote API service. It's the real object that the proxy represents. And then we have the proxy class, which also implements this interface and therefore also has a request method. It thus provides an interface identical to the subject so that the proxy can be substituted for the real subject. It also maintains a reference to and controls access to the real subject, and potentially is responsible for creating and deleting it. That's the pattern structure. A few variations of this pattern exist. The example we looked into was the remote proxy variation. Let's have a look at these variations first before we implement an example. The first variation is the remote proxy. That's the one we used as an example. The idea here is that a client can communicate with the proxy, thus treating it as a local resource. The pattern hides the fact that the actual object exists in a different network space. The client does not need to know that a remote service is called. The proxy hides away these network and protocol details. More often than not, these proxies are generated from a service definition. That can be a WSDL or, more common these days, an Open API specification. The second variation is the virtual proxy. This one allows creating expensive objects on demand. You can look at it as a stand-in for an object that is expensive to create. So, performance optimization is a big advantage of this type of proxy. Another variation is the smart proxy. The purpose is to allow adding additional logic around the subject. Typical examples are managing caching or locking access to shared resources. The last variation is the protection proxy. This one is used to control access to an object. It can be useful when objects should have different access rights. Like that, checking for that no longer has to be done by the client code or in the object itself. It's the protection proxy that's responsible for this. Sometimes the separation between these different types of proxies isn't clear. It's not uncommon for code generators to, for example, generate a proxy that both hides away the fact that a remote service is accessed and takes care of permissions and access restrictions. This, of course, is in violation of the single responsibility principle. A better approach would be to chain proxies. In other words, proxy the proxy, sticking with a single responsibility per proxy. We'll cover that with a demo. These variations all have their own responsibilities and consequences. But as far as implementation is concerned, they all follow the same structure. So, what we are going to do in an example is implement two of these. We're going to implement a virtual proxy and we're going to implement a protection proxy. That one is very closely related to the smart proxy because both allow additional housekeeping tasks when an object is accessed. As an example, we will use a document object, which represents a PDF or a text file. Imagine that this is an object that is expensive to create, which is pretty common. You might, for example, want to read out the underlying file from disk as part of the creation process, and that is quite expensive. The virtual proxy pattern can be used to ensure that creation only happens when needed. And then we'll add a business rule stating that the document can only be viewed by people in the viewer role. We will use a protection proxy for this, and we will chain that with the virtual proxy. Let's implement this.